Hello. Hello, dear students. Are you guys able to hear me? Hello. Uh, Very good afternoon, dear students. So in today's class, I'll be discussing about the construction of a hexagonal nut and bolt assembly. Okay. So are you guys able to see the screen? Hello. Okay. And what I'll do is take you to how the problem will be framed. How the problem will be framed. So based on the particular problem, how we can the construction of the particular, you can say. There is no sound. Aren't you guys able to hear me? Can you hear me? No. Are you guys able to see the screen?
Yes, sir.
Okay. You can hear me, right? Okay. So today we'll be constructing the hexagonal nut and bolt assembly. The square nut and bolt assembly will be taking into the particular chapter. Okay. So there will be some parameters that will be already given in the question. So with respect to that parameter, so what we have to find out is, you can take out the screenshot of this. Okay, first. So you will be given only the diameter of the particular hexagonal nut. Okay, so we call that as a hexagonal, sorry, nominal diameter. We call it as. Okay, so that you will be given. Then you will have to calculate the width across the flats, width across the corners, then thickness of the bolt, then thickness of the nut, then a root diameter. What you root diameter also call it as a pitch circle diameter. We call it as. Then what will be the length of the bolt that will be given in the question. Okay. Then we have to decide the thread length. Okay. So what happens? How do you decide the thread length? So usually, if the length of the given bolt is less than 150, okay, note this. Okay, if the length of the bolt is less than 150, so we will be going for the formula 2 times the nominal diameter plus 6 mm will be taking. Then will be if the length of the bolt is greater than 150. Okay, if the length of the bolt that's given in the question is more than 150, then we will be taking 2 times the diameter plus 12 mm. That is the thread length we will be taking. Is that clear? Just look at here. So you will be given only the parameters like the nominal diameter of the particular thread will be given, or the bolt will be given. Next, you will be given the length of the bolt. What is the length of the bolt? Only these two parameters will be given. Then after that, you will have to calculate these parameters. Okay, you can note these formula on the notebook. You can note it. Okay, nominal diameter, it will be indicated as D. Then width across the flats, so that is nothing but the 1.5 times the diameter plus 3 mm, right? Then width across the corners, it will be the 2 times the diameter. Then thickness of the bolt head, it will be found 8 times the diameter. Then thickness of the nut, you will be drawing as a point 9 times the diameter. That is nominal diameter only we will be taking. Then root diameter or pitch circle diameter we call it as. So we'll be drawing that as a point 9 times the diameter. Then length of the bolt that will be specified in the question. Then thread length. So there are majorly two kinds of thread length we'll be taking. Sometimes the length of the thread, sorry, bolt is uh, less than 150. So we'll be taking up 2 times the diameter plus 6 mm. If the length of the bolt is more than 150, so we'll be taking the thread length as a 2 times the diameter plus 12 mm. Then chamfer of the bolt end. So we'll be drawing the chamfering at the end of the bolt. So that is the depth of the thread into 45 degree or zero point 0.1 times the diameter also we can take directly. Then chamfer angle for bolt, head and nut. For both head and nut, chamfering angle will be 30 degree. Right? First, you note these parameters. Then we'll move on to the next how we'll be constructing using the how you will be constructing manually. I'll just tell it. Then we'll go to the Solidworks and we'll see how it can be constructed. Right? So note these all these parameters first. Okay. Okay. Did you guys take the screenshot or did you guys note this formula? Okay, shall I move on to the next page? Okay. So this is how you will be given the formula, sorry, the problem. You can note it. Draw 3 views of an ISO threaded hexagonal bolt. Draw the 3 views of ISO threaded hexagonal bolt 100 long. Okay, so bolt length, as I told the previous, okay, bolt length or length of the bolt is 100 So it is lying within 150 So we'll be taking the formula 2 times the diameter plus 6 as a thread length. Okay, note that. Then 20 diameter. That is nothing but what? That is nothing but what? That is nothing but the nominal diameter. Okay, this nominal diameter of the thread. 20 diameter and a thread length of 50 So here's directly given as the thread length here. You don't have to calculate. Then and hexagonal nut assembly in the axis horizontal position. Okay, hexagonal nut in the horizontal position. So indicate all the proportions and the actual dimensions. Okay, indicate all the dimensions, all the proportions and the actual dimension. Okay, just note it. Okay, you can just note it here. First, what you can do is, okay, draw the nominal diameter. That is 20 he has given. Okay, then After drawing the nominal diameter, what you can draw is, this is what we call it as a head of the bolt. Okay, this is nothing but the head of the bolt. So to draw that, we have the formula here. Thickness of the bolt, that is nothing but the 0.8 times the diameter. Okay, and width across the corners. So initially will be this weave, you can see width across the corners, we call it as. Okay, so taking up the weave from the another end, this, so weaving from this end, this is what we call it as a width across the flats, we call it as. If you are weaving from this end, so we call this as a width across the corner. Okay, for weaving from this end, we call this as a width across the flats, and if we're weaving from this end, we call this as a width across the corner. So you can see here, width across the corner is 1.5 times the diameter plus 3 mm. So where do you take that? Will be this way. This is nothing but 1.5 times the diameter plus 3 mm. I'll just tell you how we'll be going through this. Okay, don't get confused. Okay, I'm just telling what are the parameters that visually we go through in this particular uh, hexagonal nut and bolt assembly. Okay, this is the bolt and this is the separate nut portion, you can see. This is the bolt and this is the nut, and from the end of the bolt head to the end of the bolt, so we call that as a bolt length of the bolt. Okay, and thread length, from where do you draw it? From this end to this, whatever the length of the thread it is given in the question. So based on that, we'll be taking directly the length of the thread. You can see here. Okay, this is the length of the thread. First, what you are doing is, first you draw this particular bolt, then upon that you draw the bolt head, then you take up the nut over here at any random distance. Okay, you can take it at any random distance, but not on the end of this particular bolt. Why we should not draw the particular nut on the end of the thread is, whenever just think of practically, if you put the particular nut at the end of the thread, what happens is after some time it will just vanish off because of the threading between these, so that it may fall down because of some reason. So that's why we usually fix the nut at a certain distance away from the end. You can take it at a random place, not an issue. Okay, but while drawing the weave across the flats, you have to take the projections from the particular weave across the corners only. Okay, I'll just tell you guys how to draw it, don't worry. Okay, now what are the parameters we can see? You can see the length of the particular bolt, then head of the bolt, nut, nut you can see. So you can see the particular, what I can say, the chamfering on the bolt and bolt as well as on the nut, then chamfering on the end of the particular bolt, then in the weave across the flats, you can see when you're weave across the flats, you can see only two heads, we can see, or two kinds of, only two corners you can see. But when you're weave across the corners we can see three heads. Sorry, three corners we can see. That is the major difference between the view across the flats and view across the corner. Okay. Then this is can take up the snapshot snap of this. Okay, particular screen. Keep it for a reference. Okay. Now I'll be going through the SolidWorks how we can draw that. I'll just be showing how we will be drawing. Okay, as usual, go to new, select new, then 2D engineering drawing or typically a part or a assembly. Just click on that. Okay, here what I can go to A4 ANSI landscape and tick on the display sheet format. Just click on OK. To make sure that the dimensions are all in MMGS format. Okay, now as I was showing the hexagonal nut and bolt assembly, I'll just read out you for a particular problem once again. Draw the three views of an ISO threaded hexagonal bolt 100 mm long. Okay, I just read on the parameters here. Length of bolt mm. Then what are the other parameters is told? 20 mm diameter. That means nominal diameter, you can say. Nominal diameter. So he has given it as a 20 mm. Next. And the thread length of 50 mm. So he has given the thread length as thread length equal to 50 mm. That's given. Okay. So these are the parameters that are given. So with respect to these parameters, we have to draw the particular hexagonal nut and bolt assembly. So how do you draw that? We'll just see. Okay. First, what I can do is you can just go to corner rectangle. Just click on this. Just keep these parameters aside. Okay. Corner rectangle. Just to draw it roughly. Okay. So what is the nominal diameter? It is 20 mm. Yes. And so he has given the formula. Okay. As I was telling, with respect to the formula, we'll be taking up width across the flat. When this width across the flat is there, the head diameter, we can do is from here, we'll just draw it roughly. Here to here is 10 into So here it should be, so total it will be 40 mm. Right. Why did I draw this? I take these parameters like this. Just look at here. As he has told, the formula you might have taken the screenshot. Okay, width across the corners. Okay, width across the corners. Like this width will be 2 times the diameter. So what is the diameter here? 20 mm. So 20 into 2, how much it will be? 40 mm. So I've done it in the other ways also. I'll just again. What you can do is you can take the center line for this. Okay. And just extend the line. Okay. So from here to here, it should be 20 mm. Okay. And you can just mirror it to about this center line. Also the same thing, whatever we are doing. Okay. Now, front, you can just extend these entities and connect. Okay. Now we have this particular head width across the flats. Then he has told the width of this head is 0.8 times the diameter. Right? It will be 16 mm. Okay. That will be 16 mm. That will be directly given from the formula. Then the length of the bolt. What is the length of the bolt? He has given the formula problem. The length of the bolt is 100 mm. Okay, you can take this as a 100. Okay, right. Now we have the head of the bolt. Right. Now what I can do is to draw the chamfering on this. As this is 10 mm, right? As this will be 10 mm. So what I can do is for that, first what is we'll draw the arc for this. Okay, so arc will be, first you can just take a rough line over here, then you give the angle between them is as a 30°. Okay. Then you can just remove these unnecessary lines. Okay. From here, from here, this has a radius. You can draw the arc on one side. Okay, you can go to mirror and just mirror this particular arc about this center line. Now we have the arc of or a chamfering, what we call it as chamfering on this side. Right. Now, after drawing this, after drawing the center arc, now what we have to do is uh, from here, just connect it to this. You can just remove this so that you can get the center point again here. Okay, so go to center point arc again, select this and go to mirror, select this, click on this and a mirror over here. Okay, now what I can do, can mirror this complete arc about this center point. Now you see we got the chamfering, right? How do you draw the chamfering? We just look at here once again. First, what I can do is I'll just go back, just show it once again. The arc. Okay, see here you can just select the center line. Okay, from here you just first you draw the rough line, you draw it, then go to smart dimension. You select this bottom edge line and this center line, you select it. So you give this as a 30-degree. Okay, then go to trim entities, trim off this additional so that you can get a point over here. Okay, then you go to center point arc, click on this center point, then go up to this center line, then you draw the arc on either of the side you can draw. Okay, just click on this. Now you have the arc. So you go to mirror entities, go to select this arc, so mirror above the center line, then click on OK. Now you have the arc. Now how do you draw the arc on this edge? Right? To draw that, what you are doing is, so again, either you can select a line or a center line. I'll just select a center line. Anyway, this will be around 10 mm. So the center point for this will be 5 mm. Just click on this and you are OK. Then you trim off this additional line and just away. Then go to center point arc. Just click on this, extend up to this end. So you just connect it to this line. Now we have got a arc. What you can do is you can go to mirror entities, select this arc, mirror about this center line. Now you have the arc. Now what I'll do is I'll mirror this but whole arc, so about this center line. Sorry, about this center line. Now I have the arc of or chamfering on the corners of the particular bolt. Right. So what are the parameters we got now? We got the length of the thread, right? We got the chamfering also, right? Now what we have to do is we have to draw the particular bolt, a nut over here. We'll just select a rough line initially. Anyway, the length of this will be 40 mm only, and only the parameter that we are worrying is this one. So this is nothing but 0.9 times the diameter. It will be 18 mm. So this distance you can give randomly. So for
ಹುಡುಗಿ ಆನ್ಲೈನ್ ಕ್ಲಾಸ್ ಗೊತ್ತಾಗೈತಿ
ಅವ್ರ ಜೊತೆ ಮಾತಾಡಿ ಲವರ್ ಬಗ್ಗೆ
ಇನ್ಸ್ಟಾಗ್ರಾಮ್ ದಾಗ ಏನಾದ್ರು ನೋಡಿಲ್ಲ ನಮಗೆ
okay. We can just place it around and the same distance you can use 0.9 times the diameter or around 20 mm or 25 mm. Just give it from this end. Okay, you can just give more than 10 mm or 20 mm. Now what I have to do to draw the arc or a chamfering on this end also, the same manner how I have drawn it for this bolt, the same manner I'll be drawing it here also. What I can do, I can go to this center line. Okay, select one of the, sorry, go to center line and select one of the corner line and I give the angle between them as how much, 30 degree. Okay, so you can remove this additional line. Next, what you are doing, go to center point arc. So click on this point, click on this. So either of the ways you can select. Now the arc is drawn. You can do it, just mirror arc about this. Now the similar manner how I've drawn here, and just take the reference of the previous one. Okay. Just remove this additional lines. Go to center point arc, click on this. And just click on this, showing it. Now just mirror this arc to this center point. Okay. Now mirror entities. Just mirror this arc about this center line. Now see, we got the bolt portion also. Sorry, nut portion also. Okay. Just name this. This is bolt. Okay, this is the bolt portion, and if we're taking up, this is nut. Okay, this is nut. Got to know how to draw this, right? That is the just this is nothing but what, So there is nothing what about length of the bolt. That is nothing but the length of the bolt. Now what is remaining is the particular thread, drawing of the thread on the particular bolt. So how do you draw that? I'll just show it. So here roughly I'll just take a rough line. Okay, you can just take a rough line. The length of the thread he has given. Okay, the problem is given the length of the thread or a thread length of 50 mm he has given. So what I can do is from here I can give a 50 mm. Okay, so what will be the diameter of the thread? We can check it in the formula. So thread diameter, or what you can say, thickness of the particular root diameter, we call it as. Okay, so from here to here, it will be actually, or if you're taking up the same thing on both the sides, first what you do is take up these two lines and mirror about this, and the length between these must be 0.9 times the diameter. Okay, you have to do this first. Okay, so this gives us the thread on the particular nut, sorry, bolt. Okay, so this is how you draw the bolt or root circle diameter. Root diameter we call this as. Okay, so that will be giving us the particular we have to draw the chamfering over here. So how do you draw that? Just go to H chamfer. Just click on this. Chamfering you can do one by one. You can okay, even on the other side also. Okay, okay. This is the chamfering you can see. One by one you can take. Okay, so this gives us the chamfering on the bolt end. Now you see how we have drawn the length of the thread on the particular bolt. Next, what will be the parameter we have to draw? Okay, the particular right wave. We have to draw the right wave also. So how do you draw that? You can go to this polygon and take the reference of this center line. It should be 90 degrees. And just check this out. It should be 40 mm. Okay. So we are drawing the wave of this front wave when we are looking from this side. And just take an arrow mark. From this end, when you are weaving, how that will be looking like, how this particular wave will be looks like, right? So what are the things we can see? The diameter of this nut and bolt will be merging, and we can see this particular root diameter we can see from this end. Okay, then what else we can see? These both diameters, we can see the diameter of this particular nut we can see. Also results we can see only those things, right? And these chamferings we can see, how we can see, how we will be going through that. We'll just check it. So first up to draw the diameter of this particular. So this diameter will be 18 mm. Root circle diameter. Actually, that will be having just 1/4 of the circle you can draw. Okay. 0.9 into D, that will be 18 mm. 0.0 E divided by 2 will be 9 mm radius it will be. Usually pitch circle will be drawn 1/4 of the circle. Then will be drawing the one more circle having the 20 mm diameter. Next, this is the chamfering diameter. This is this particular diameter. That will be automatically taken. You don't have to worry about that. Okay. When you are giving the particular length of this particular thread, the bolt height of the bolt, if you are giving bolt head height, if you are giving, so it will be automatically taking the other kinds of diameters as well. Okay. Okay. Now what I can do is, now you see this weave is called as weave across the flats. This is weave across the flats, we call it as. Just make the letters bold and can make large. Then which kind of weave is this? This is nothing but the weave, right side weave or a right weave. We call this as a right weave or a right side weave, we call it as. This is the right. Now we have to draw the weave across the, sorry, this weave across the corners, okay, not flat. Weave across the. Now we have to draw the weave across the flats. So how do you draw that? That means when you're weaving the particular nut and bolt assembly from this weave, okay, how do you draw the weave across the flats? Same. What you're doing is you're just taking the projections from this end, okay, and take the projection from this end as well. Projection. Just initially draw line, and you can 45-degree line for this. Okay, and remove this additional line. Okay. So from here, you can draw straight line. Okay, this is the center. Okay. Then from this side, and take a projection similarly from this end. So you can take a okay. You can just remove these unnecessary lines. Okay. Now see the length across the flats will be the bolt and a nut length across the flats will be taken from this end. Okay, when you're taking it the projection, it will be automatically taking the length of the length of the particular head in the flat weave across the flats. You don't have to draw the particular weave across the flat head again. Okay. Only thing that you have to draw is you just take up a straight line. The distance between the dimension for this will be taking as a take a straight line. The dimension as 10 mm. Just trim this. Go to mirror. Just mirror about this. Okay, this line will be acting as a center line for us. Okay, and just remove these lines. Similarly, this line as well. Okay. Similarly, you'll be taking the projection. You can directly extend the lines. Similarly, these also can extend it. So first, what we'll do these projections, then we can delete those lines. And these lines. Now what I can do is you can just remove these unnecessary lines. Okay. Now you're having the projection. Okay. Now this particular length of this thread, it will be just roughly draw it first and take up this, then take a mirror, go to this center line. It is not a straight line, midterm horizontal straight line. This into vertical line. And just take this as horizontal lines. So what was the distances? Okay. Similarly, now what I can do is go to chamfer, chamfering for this. Similarly, this side. And the major thing that is remaining is making the chamfering on this nut and bolt. So how do we take the chamfering? How do you take the chamfering? Right, I'll just allocate here carefully. First, what you have to do is just measure this distance, 17.32 it is. Okay, keep it as it is. First, you draw a rough line over here. Okay, then use this distance as 17.32 divided by 2. Okay, what I'm doing is at the center point of this line, I'm drawing a one more line here. What I'll do is I'll take a rough line from this point. What I'll do is I'll extend a straight line over here. I'll trim this. Go to line, select this line. Next, we draw a perpendicular line to this. Okay. To draw from here, what you do is you draw a perpendicular line to this. When you measure the angle between this and this, it should be 90 degrees. Okay. Now what I can do is you can just remove these additional lines. Go to center point R. Select this as the center point. Okay. Then you draw the arc. Either this side you can draw the arc. Then go to mirror entities. So mirror about center line. Okay, next again what you can do is just mirror the whole arc about this center point. Now you see In the same manner, we are drawing over here also. Okay, what I can do is just extend this line to this. Okay, it is the center point. Obviously, the same center point will be there for this also. Okay, only thing that we'll be worrying is this line. What you can do is you can take a line from this point to straight line. You can take next. Next, what you're doing, connect this point to this, having this center line. Or what you're doing is you're drawing the perfect perpendicular line to this line. This line. Now what you do is you just remove the unnecessary lines. Okay, go to center line, center point arc. Click on this point and draw the arc. Either of the ways you can draw the arc. Then you can go to mirror entities. You can select this to mirror about this line. Carefully you have to select it. Okay, now you have the arc over here. What I can do is go to mirror entities, select this arc about this center line. Now see, we got the arc on both the sides. This is how usually the particular arc for weave across the flats and weave across the corner will be drawn. Okay. Here what I can do is you can just remove these lines. So these are the reference lines. Keep it, or you can just remove. Similarly on this side also what I can do is remove these. The other side also. Then just trim it. And so want again the lines that are already drawn to be very thick and all, you can give the two kinds of lines. Okay. This is how the particular weave across the corners and weave across the flats will be drawn. You just name it as weave across the flat. With reference to weave across the corner only, we are drawing weave across the flats as well. We are not drawing any extra things over here. Whatever the drawings have been drawn in the weave across the corners, we are taking the Those as a reference and we are drawing it. That's all. Right. So any doubts so far in this? You can just do same. Name it as a code assembly. Just name it. So here you can name it as a hexagonal Nathan assembly. So you try solving this. Whatever the manner we are drawing here, the SolidWorks, the similar manner will be drawing manually also. Okay. So any doubts so far in this? Right. Just look at the figure. Square nut and bolt. Sorry, hexagonal. Right. This is the hexagonal nuts and bolt assembly. With respect to the parameter that were given to us, so we have drawn the hexagonal nut and bolt assembly. Right. Any doubts so far? Hello. Are you guys able to hear me? Any doubts, dear students? Because I'm going to start one more nut and bolt assembly, that is square nut and bolt assembly I'll be beginning with. So if you have any queries over here, just look at the figure and let me know if you get any doubts in that, so that we can continue with the other. Just to see how I've drawn it, and first view across the flats corners you can take. So you will be given the diameter of the particular nominal diameter of the particular bolt. So you are taking up that. So I'll just draw it once again just to see. Okay. Just take a rectangle. Draw the nominal diameter first. That is 20 mm is given. With respect to this, what you can do is you can take a straight center line, draw a straight center line. With respect to this, what you are doing is you are drawing a rough. So this should be 10 mm and the length should be 0.8 times the nominal diameter. It should be 16 mm. And what you can do is you can just go to mirror and mirror this about this. Now if you want, you can just extend these entities. Now we have the particular head of the bolt. Now what I can do is you can fix up the length of the bolt. So as he is given it in the problem only, it's 100 mm. Now, so what you have to draw for drawing this? You can directly draw the chamfering without wasting much of the time. Okay, you can take a line. Okay, and just roughly you draw a 7 line, and okay, you view the angle as a 30 degree. Okay, you can just remove this additional line. Okay, now from this center point arc, you just select it. Tell this as the, just click on this. Okay, now remove additional one. You can just mirror, so mirror this arc above this line. Right. Now, how do you draw the arc on this end? Okay, similar way, what you do is just take a line. Okay, just measure, it should be 5 mm this end from this end. Okay, now what you do is just mirror it. So mirror about this line. Okay, so you're having this 30-degree line, right? So you can just connect this here. Okay, now what I'll do is I'll just remove this so that you can get the center point to draw the arc. You just zoom it. Either the side you can draw the arc. Now we have the arc, mirror and face about this. So you have the arc. So what I can do is to go to mirror and arc is selected, so about this one. Now you got the chamfering on the one of the on the bolt head. You got the chamfer. Similar way, what you can do is you can draw the this as the reference and roughly draw it. Okay, and take the dimension. This is nothing but 0.9 times the diameter, that is 18 mm. So from this end, you can put some money of the dimension you want. Earlier, now also I'll give the 25 mm only. Now, similar way as I've drawn the arc over here, you can draw the arc for this also. Roughly, you can just give the angle between them as 30 degree. Okay, so just trim it out so that you can get the center point. Go to center point arc on this. Draw the arc on either of the sides. Okay, then remove this additional line. Now you can go to mirror this. Go this line. And now, as a drawn a line, what I can do is you can just extend these entities over here. Okay, don't get confused. Okay, now you can just trim off this line so that you can get the center line to draw the center point arc. Select this, select, you can draw the arc and remove additional arc here. Now go to mirror. So mirror. So mirror this arc to about this point. Now, again, what you're doing is and mirror above this. Now you see, now we got the bolt also, that is having a distance. Now what I can do, you can draw the thread over here. Roughly, so it initially just remove this additional line, right? So you can just mirror this both the center line. You can have it on both the sides. Now in this dimension and some 0.8 diameter, that is 18 mm on both the sides. Right. Now you can have a chamfering on this. So one by one you can give it equal to 1 mm. Here you can give one on the other side also. You can give that. Right. Have this chamfering. Even on this side. So you have this chamfering damage. So we got all the things. Now what I can do is I can draw the side view of this, right side view. Okay. The polygon, yes, hexagonal you have to select. Okay, both the sides should be there. You just make sure that this is a 40 mm, because this length is length of this particular head is 40 mm. Then you have to draw the VCD, that is the circle diameter inside that. So that must be done 1/4 of the circle in just the actual bit of that. So that should be the radius of that must be 9. Okay. Similarly, we'll just draw our circle over there. This diameter must be 10. So 20. Diameter is 20, the radius is 10. Right? This one, instead of construction, you can just put a straight line itself. Now we have the side view as well. Okay. So we got the side view also. Okay. Now we have to draw the, this is view across the corners. This is view across the right side view. Then we have to draw the flats. View across the flats. To draw that, what you are doing is taking the projections. Okay. Projections. So what I can do is I can get line 45 degree over here. So it must be 45 degree. Right? Then just remove line now. Now get line. Now what I do is take the projection from this. Okay, and hit this also. And the projections. Okay. Here, okay, taking the projection particular line, you can make it for construction. That means this is the centralized for this. Okay. And I can go to line. So it's okay. Okay. So you can just mirror this line. So about this, you can just so you can put the dimension as okay. Now you have to align such that dimension must be, and we are drawing this. Okay. So we get this. So just do this. Yeah. So here, now you can just draw a straight line. So this should be 9, right? For the ends, you take up 18 mm. Mirror it. The distance between them must be 18 mm. That's all. Then the important thing that we'll be doing now is we'll be drawing the chamfering over here. So how do you draw that chamfering? So first you check the distance for this. So 17.32 again, wearing the same distance, right? So you just draw a rough line over here so that the distance between them from here to where the distance must be 17.32 divided by 2 is 8.66. Now what you do is just extend, so you take a straight line. In this point you just extend the line. Okay, let's remove the additional line. Okay, just join these 2 points, then draw a perpendicular line to this. Okay, this indicates this, you can see the perpendicular signature or the symbol there that indicates that the line is perfectly uh, perpendicular. Okay, you can just zoom it. Just take, we will be getting the center point for that. Now then take this as the center, draw the arc. Just mirror this arc above the center point. Now go to this as the center point. You can get the, you can just remove the additional arcs. So similar way, you are drawing the arc on this side also. So how do you draw that? Then go to the line. Okay. From here, taking a straight line over here. Remove additional lines. Okay. Now go to line. First, you just extend this line. Extend it this. Extend it this way. Okay. Now from this side and to this. After getting that, what you can do is from here and draw the perpendicular line to this. Now what you do is just go to trim, remove these so that you can get this. Remove this. Go to mirror entities, mirror, select this line carefully so that it is mirrored. Then after selecting this, go to mirror entities again, select this complete path. So mirror about this center line is selected. And we have this particular weave across the flats also. Okay. So any doubts so far in this? I've drawn it twice. Result the chamfering. Okay. So usually the hexagonal nut and bolt assembly will be drawn. So any doubts so far in this? Any doubts, dear students? You must know which command should be used for which purpose. That's all. Okay. Okay, dear students, then we'll wind it up here for today. We'll meet up in the next class. Any doubts then? No doubts? Okay, fine. Yes, Abrar. Okay, fine then. So you guys practice if you're having a system at your home, get it installed this particular Solidworks software. You practice it. So if you got any doubts while practicing, you feel free to contact me. Okay, we'll resolve the problems. Okay, we'll solve the problems. Okay. Okay. If fine, then we meet up in the next class.
Yes, sir.
Okay, guys. Thank you. Thank you very much. End the meeting.